In this video, we are going to solve the following related rates problem. A ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 4 feet per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? So first, let's draw a diagram so we can make sure we understand the situation. So first I'm going to draw the ground, and now here I'll draw the wall. And so I'm given that a ladder is resting against the wall, and the ladder is 10 feet long. So this length in red, the ladder, is 10 feet. Now, I'm given that the bottom of the ladder slides away from the wall at a rate of 4 feet per second. So I know that the ladder is sliding away from the wall at 4 feet per second. And I'm being asked, how fast is the top of the ladder sliding down the wall? So I'm looking for this rate when the bottom of the ladder is 6 feet from the wall. So let's start by labeling some variables. I'm going to let x be the length of the bottom of the ladder away from the wall, and I'm going to let y be the distance from the top of the ladder to the ground. Now, in terms of x and y, I have that dx dt is equal to 4 feet per second. And what I'm being asked to solve for, which is written in green, is dy dt when the ladder is 6 feet from the wall. So basically, when x equals 6. Okay, so I've basically gathered all the information from the problem and written it down in some quantitative matter, but now we have to piece everything together to solve this problem. So first, can you think of an equation that can relate my variables x and y? Well, if you see here, we have a right triangle, right, with side lengths x, y, and 10. So I can write the following equation: x squared plus y squared equals 10 squared, which is 100. Great. Now I can differentiate both sides of this equation with respect to with respect to t. So what does that look like? Well, this would become 2x times dx dt plus this would become 2y times dy dt, and then this is just a constant. The derivative of a constant is 0. So I get the following. Okay, now I want to try to isolate dy dt since that's what I'm solving for. So first, let me subtract this from both sides. So I have 2y times dy dt equals minus 2x times dx dt. Now I can divide both sides by 2y. So I get dy dt equals negative 2x over 2y times dx dt. These 2's cancel out. So what I'm left with is dy dt equals minus x over y times dx dt. Great, so we're so close to being done, right? We want to know what dy dt is when x equals 6. Okay, so let's go ahead and plug that in. So what is dy dt when x equals 6? That's going to be minus 6 over y times dx dt. What is dx dt? That's written right here. That's just 4. So I'm going to plug in 4. Now what is y? Well, we can solve for y using the fact that x squared plus y squared equals 10 squared, which is 100. When x equals 4, or when x equals 6, what is y? So let's plug in 6. So this means that y squared equals 100 minus 36, which is 64. So this tells me that y is plus or minus 8, but in this case we're only looking at positive values since we can't have minus 8 feet. So we get that y equals 8. So now I plug that in. I have minus 6 over 8 times 4. This is minus 3. So what is this telling me? This is feet per second. And the fact that this is negative means that the distance from the top of the ladder to the ground is decreasing at that rate. So in other words, this tells us that the top of the ladder is sliding down the wall at a rate of 3 feet per second. And that is our final answer. So let's do a quick recap of what we did. So we were given the following problem. We gathered the information that we knew and we made a diagram. We labeled the information we wanted to find, and then we used an equation to relate the two variables we're given. So in this case, we have the length of the ladder, the bottom of the ladder from the wall, and the top of the ladder from the ground. And those are our two variables, and we related them using the Pythagorean theorem. Then we took the derivative of both sides of that equation and solved for dy dt, which is what we wanted to find. And then we used the information we were given to fully solve the rest of the problem. If this video was helpful, feel free to like and subscribe.